Foreign faculty, Professor Antonio De Feliz from Kyoto University. Our guest of honor, Professor A.N. Mitra, Professor Sami, the research director of the Jamia Millia Islamia, Professor Ghosh, Professor Jairaj Puri, the GAN coordinator of Jamia Millia Islamia, the senior faculties, professors, distinguished guests, the participant, students, friends. It is a pleasure to welcome you all to this GAN program on the introduction to cosmological perturbation theory that will be delivered by Professor Antonio De Feliz from Kyoto University, Japan. It's a pleasure that this is our third series of GAN lectures. We already have 2 lecture series in Center for Theoretical Physics, and this is our third lectures. And there are previous 2 lectures. Here also we see a lot of enthusiastic application from all over India. We have at least around 56 participants from all over India, and I hope all of them will have a very fruitful academic and social life in Jamia for next 1 week. So welcome you all on behalf from the Center for Theoretical Physics, and I request Professor Sami to say a few words.
Professor Ahmad, Vice Chancellor of the University, Professor De Feliz from Kyoto University, Professor Mitra, eminent physicist of the country. Actually, this is a really great honor for the center to hold this GAN program. This is the third, as Anjan Sen said, this year, the center is organizing. Okay, it's really pleasing that many students registered for this program. We couldn't accommodate everyone. And a large number of people for this workshop have come from different places of the country. Actually, and I'm sure that many of you are here in this center for the first time. So let me say a few words about this center. This Center for Theoretical Physics was established in 2006 as an autonomous research center in the university sector. And the idea of this center was inspired by Ayuka, by Jayant Narlikar. So, Jayant Narlikar said that, look, it's extremely important to have a research center working in the university sector. Well, humility doesn't allow me to say that this is a successful research center. Let me refer to the words of Narlikar. He said in 2011. Actually, in 2011, the Nobel Committee on Accelerating Universe cited a paper written from the center. In fact, it was the first paper written from the center. And Jayant Narlikar was interviewed by Indian Express. It's very, very rare that he appears in the press. So he said the following words. He said, the Center for Theoretical Physics at Jamia Millia Islamia is the unique research center that has succeeded in the university sector. Actually, it's not easy to make a center working in the university sector. Research centers are different. Well, their structure is different. Here, the stress is on teaching departments. Well, if a department can work for years and years without doing much, a research center is vulnerable to fast demise. In my opinion, there are 4 broad requirements a center should meet in order to succeed. First, there has to be a long thinking, a clear-cut vision before a center is created. Let me tell you, this center meets this criteria. Actually, Professor Usmani is here. This long thinking and clear-cut vision existed thanks to him. He was the one who formulated the idea of this center. So, center meets the first requirement. Second requirement is that the center should collect a vibrant, competent faculty. It would be arrogant on my part if I say that we are a competent faculty. Actually, Professor Mitra is the right person to tell you. Professor Mitra is a legendary name in Indian physics. Several generations of physicists have learned theoretical physics from him, directly or indirectly. He was the one who appointed as an expert the faculty for the center. He appointed all of us. And he's the one who is closely monitoring the progress of the center for past 10 years. So he will tell you whether we are up to the mark or whether we have really done as he wished us to do. Third, it's very important for a center that the research community, our colleagues in the research institutes, support us. Let me tell you that the Center for Theoretical Physics has a very vibrant visitors program. And this is the backbone for this center. So, within this program, our colleagues from research institutes keep visiting us. They lecture to our students, they collaborate with our faculty, they have written papers with our colleagues and students. So we meet this criteria. Last but not least, it is very important that your research center enjoys the support of the university administration, allow the Vice Chancellor. See, universities are very different from research institutes. In universities, Vice Chancellors are very powerful. And if you do not have support of the Vice Chancellors, your center cannot succeed. Let me tell you that we are lucky, this center is lucky to have had very strong support from the beginning of these Vice Chancellors. Center was created in 2006. A dozen of centers were created in 2006 by Professor Mushirul Hasan. Professor Mushirul Hasan did a remarkable job for this university. So, the idea was that he used to say that, look, Jamia is not DU. Delhi University has eminent people on its panel. Historically, eminent people were associated with it. Jamia cannot compete in that respect with them. A name like Professor Mitra is associated with DU. We never had people like him here. And then you have JNU. JNU, eminent people were gathered from all over the world. Huge funding was made to this institution. And again, we cannot compete with JNU. So he used to say Jamia could distinguish through these research centers. So in my opinion, he did a remarkable job, but not every center had that thinking, like the Center for Theoretical Physics. I'll not comment on other centers here. So actually we meet all these criteria. These four broad criteria were necessary, not sufficient to make a center successful. Well, after Mushirul Hasan, his successor also supported us. His successor is an administrator, and in the beginning, actually there were some problems. We took little time to convince him that Center for Theoretical Physics is really working very well. Thereafter, he lended full support to us. In the fall of 2014, Professor Ahmed joined us as a Vice Chancellor. And before coming here, he knew about the center, he knew about us. He is a fellow of all three academies. He is fellow of J.C. Bose fellow. So this time, there was a smooth transition. It was very easy to work with him. Whenever I go to him with proposals, he always says yes. So a research center should get young entries all the time to sustain the work. So recently I requested him to give us some positions. He kindly agreed to give us 3 positions. And this is the way. Okay, it's not easy. If you do not get positions from UC, Vice Chancellor manages from somewhere some positions for you. I'm really thankful to him for this. As I told you that The visitors program is a very vibrant in the center. Many experts from abroad keep coming. Antonio De Felice has come to us for the first time. Actually, it's great that in 2011, Jamia Millia Islamia offered him a faculty position. At that time, he was in Thailand. Probably it was the most crucial time for him, which decided his fate. In fact, he got a position, very good position in Kyoto, in one of the best world research centers. It was a win-win situation for him because his wife also from Japan. So he joined Kyoto. Okay, so the ritual of this program demands that I should say a few words about the speaker in the chronological order. So Antonio was born in Italy in 1974. He did his MS there. Thereafter, he went to US. He did his PhD at Syracuse with Professor Mark Troden, an eminent cosmologist, great man. All of us know. The whole community knows him. Thereafter, he went to Sussex as a postdoc. In 2009, he was awarded a very prestigious fellowship in Japan. He joined postdoctoral fellowship with a collaborator of mine, Shinji Sujikawa. And it was the time when I interacted with him. And 2011 was a very difficult time for him. He was looking for a job. So he got a faculty position in Thailand. It was the time when Jamia Millia Islamia made an offer to him as a temporary faculty because our rules do not permit to give permanent positions to foreign nationals. Well, what was that which brought him a name and fame in 2011? Actually, since this has a direct link with the workshop, let me say a few words. He did a great work on massive gravity, 2011. I'm not surprised. First of all, he has a great background, and Thailand is a great place. It's a very good weather, lot of fruits around, very good people, everybody is happy and smiling. You see a lot of food around on the streets. So in such an atmosphere, you can always do a good work. And there was a pressure on him, actually. So he did a remarkable work on massive gravity. What is this massive gravity? It is for students, because it has a direct link with the workshop. Okay, so our students, the physicists know about electromagnetic field. They know the Young-Mills field. All these fields are gauge fields and massless. We can have massless scalar field. But gravity is very, very different from it. Gravity is not written as a quantum field theory or field theory. So it is very trivial to give a mass to a field. Just put it by hand. It's not easy to give a mass to a graviton, which is a carrier of the gravitational interaction. So in 1939, as early as 39, a theory of massive gravity was written by Pauli and Fitz. Great people, great names in the physics. And up to 1970, nobody looked at it. It was a very difficult problem. In 1970, Van Dam and Weltman showed that this theory is inconsistent. If you turned off the masses of the graviton to zero, you do not recover general theory of relativity. So there is a discontinuity called VDV discontinuity. In 1972, 2 years later, a great Soviet physicist, Weinstein, pointed out that this theory is inconsistent because this theory is linear. So you have to put it in the nonlinear background. The theory was put in the nonlinear background. It developed a ghost, which means instability. So it's something like this. You want to give a lesson to your bad neighbor. You appoint a don to do that. He will do the job, but he will take care of you also. So the theory with ghost is inconsistent. So this was a no-go theorem. So it was concluded that guys do not put mass to graviton. It is not correct. See, it happened 40 years later from the Pauli-Fitz theory. Again, 40 years later in 2010, Gavadaze and his group could find a correct mass of the graviton such that this theory was ghost-free and it didn't have the discontinuity. It was very good. Finally, these people had to apply it to cosmology. It was the main aim. It turned out that the most popular solution, the flat solution, is not possible in this theory. Only open and closed backgrounds were possible. And here came the punchline at the work of Antonio. It was necessary. In physics, you can find many solutions, but you have to test these solutions for stability. So, testing for stability needs to do cosmological perturbations. This workshop is on cosmological perturbations. This is a very difficult problem, and in massive gravities was so difficult that nobody dared to attack this problem. It was Antonio. There was a pressure on him at that time, who really took this problem and did it with his collaborators, Japanese collaborators. And they wrote few papers. First paper was in PRL, and this was the work, great work, which brought a great name to this man, and an offer from Misao Sasaki from Kyoto came to him. So actually this is how Antonio is the making of a great physicist. There was a lot of struggle, only he knows. What do you feel after so many years of work without job? So Antonio got a job there. So guys, this is the connection with cosmological perturbations. And I am sure you are going to have a very hectic and interesting week ahead. Antonio is a very student-friendly, very gentle, polite person. So get as much as you can from this man. I am sure you will enjoy this workshop. Thank you for your attention.
I now request Professor A.N. Mitra to say a few words.
Professor Talat Mahmood, Vice Chancellor, Jamia Millia, and Professor Antonio G. Felice, Kyoto University, Japan, and Professor M. Sami, who is the dynamic force behind this entire project, and distinguished guests, ladies and gentlemen. It's really a great honor for me to be asked to attend this function, and though I am not sure whether as an outsider to this field I really deserve this honor. On the other hand, I have been associated with the activities of Jamia for a very long time. I should say at least 3 decades, if not more. So therefore, I feel very greatly honored to participate in today's program, in which the Gyan course on Introduction to Cosmology and Cosmological Perturbation Theory. Now, this is a highly specialized topic, and as an outsider, I can only feel impressed by the amount of work that already seems to have been incorporated in this program. Unfortunately, I am not in a position to make very detailed or critical comments in this field, so I must be excused for that. But the fact that what Professor Ahmad has just what Professor Sami has just mentioned, that it is he has given a very good description of the nature of the magnitude of the work that already has come from this institution. And I'm sure that this is only it's not just a beginning. It's, even though it's only a few years since this work has started, it has already been highly impressive, and I'm not able to tell you about the details of work, but this much I realize, that in cosmology, it is of great importance to understand the behavior of a cosmological background solution. And it is in this field that we have a possibility of that a theory allows for the evolution of a universe which is consistent with the present data, as well as a solution that is called in the technical language a stable solution. The study of this stability is extremely important because it sheds light on the crucial issue of the properties of the degrees of freedom which emanate from the theory and define it in great detail. In particular, through cosmological perturbation theory, we can identify a cosmological background whether a mode is stable and find the speed of propagation as well as the mass of this mode. Therefore, I'm afraid I will not be able to go into the technical details of this field, but I should like to mention particularly that the presence of Professor DeFelish in this is extremely appropriate, that it provides the impetus to the workers in this field. If I may mention the objectives of this class of activity, is essentially threefold. The first one is to understand the Lagrangian approach of perturbation theory in order to study both the background as well as the perturbation fields. The second one is to understand how to build gauge invariant variables. Now this is a non-trivial activity. Gauge invariance is something which sort of gives a natural connection to several other fields, because several other fields under the general title of quantum field theory. Gauge invariance is something on which one can express many deep ideas, and without now. I'm sorry, I made a mistake here. Gauge invariance is basically at the very root of the entire program, and I'm sure the experts here who work in this field recognize the importance of gauge invariance as a key ingredient of this program. Now, if I may give some indication of the program, the lecture-wise course plan, which starts from today, is the very first one, the Friedman-Lemaitre-Robertson-Worker metric. This is the basic object, and it's an exact solution of Einstein's field equations of general relativity. And this is now the other details are technical, but well, I think I'll be doing injustice to the field if, as a rather I'll be doing injustice to this field if I go into the details of. I would rather be satisfied with the objective which is listed within in the program itself, namely to understand the Lagrangian approach of perturbation theory in order to study both the background and the perturbation fields. Then the other objectives are to understand how to build gauge invariant variables and why gauge invariance is central idea for this study of cosmological perturbations. Now, gauge invariance is the feature which connects to general field theory as a key feature without which the invariance of the field is incomplete. So, in a way, I should say that gauge invariance is the connecting link between this particular program that you have with, in cosmological perturbation theory and quantum field theory in general. Gauge invariance is something on which I suppose a full-fledged lecture can be given, but I'm sure those of you who are working in this field are already aware of the importance of gauge invariance. Now, the Friedmann-Lemaître-Robertson-Walker metric is an exact solution of the Einstein field equations of general relativity, and it is homogeneous, isotropic, expanding universe that is a path connected but not necessarily by simply connected, but the general form of this metric follows from the geometrical properties of homogeneity and isotropy. And Einstein's field equations are only needed to derive a scale factor of the universe as a function of time. That's the important issue, that when you talk about the universe, its scale factor is the most important ingredient for understanding its working. And the scale factor of the universe is not a constant, rather it is a rapidly varying function of time. And so I'm afraid I cannot go into the essential details of this field. So therefore, I would like to give you some only general features which introduction to I'm afraid so I would rather like to end by saying that the lecture-wise course plan of this program is quite comprehensive, and so it is instead of trying to explain or instead of trying to elaborate on in this field, I would rather look forward to hearing some of the talks that are going to follow. So with these words, I'm afraid I have not been very elaborate in my discussion, and it is and I will rather listen to what my colleagues have to say. Thank you.
Thank you, Professor Mitra. I just now request Professor Felice to say a few words.
So thank you, everybody, for coming here. I enjoy so much the this welcoming atmosphere here. Everybody is so kind to me. I want to first thank, first of all, Professor Sami, because, by the way, I liked a lot the speech, actually. I would have liked the speech would continue for, say, half an hour more, because I was really, and you managed, actually, you look into my heart, actually. When in 2011, you were saying that it's true. So nowadays, for researchers, it's it's really, we are students. As a student, I didn't know anything about the cosmological perturbation theory, actually. So little by little, by discussing with some people, reading some books, mostly working on my own on some projects, actually. Then I learned what is this field, actually. So when you students, you will look for a job, people will look for some expertise you have, right? So I think it's very important that you students try to build up your own way of doing physics. It could be that you like to work on something, okay, then you should know that thing very well. So then other people say, okay, so we have to work on this stuff, let's work with this guy because he knows very well what he's talking about on this thing. But I am very, very happy to be here. My first time in India, actually. And I came to know Sami probably in 2010 or something, actually, in Japan. When Sami visited the group of Shinji Tsujikawa, he was my boss at the time, I was his postdoc. And I met Professor Sami, and I said, oh, this is such a very nice guy. I mean, it's good when you have somebody who works in your same field, actually, and and also it's also very nice. You can talk to him about anything you want. You can share your your worries, and Sami has been constantly contacting me, actually. I had to say this one in the years, actually. Maybe an email over here, over there, once in a while, and I felt his presence all over the years. Just to say, hey, Antonio, how's it going? Hey, how are you? And then recently he asked me to come here for this Gian lecture series. I said, wow, that would be great, actually, if. And then actually, I'm happy to see you here, actually. So, I think that there is always a why. There is always a reason why we are doing things at certain times. So, I hope that this experience of mine here will enrich the students, motivate you. The job is not easy, right? Because theoretical physics. But theoretical physics is beautiful, actually. This is what drives us, to keep on working on it, actually. And Sami gave a very nice introduction of massive gravity, actually. I don't think I can add anything to what he said. But, so the hope is that I can give you as much as I can in terms of how to build up your own knowledge of cosmological perturbation theory, actually. For people who are interested, there are always new theories coming almost every day. And those theories must be checked, whether they are sensible or not. One, against data. That's also an extremely important point, actually. And the other one must be checked whether they are sensible in a theoretical way. do they lead to inconsistencies or something? And that's exactly what cosmological perturbation theory is useful for. Anyhow, so thank you very much for the students who came here. And it is my great pleasure to be here. Okay, thank you very much.
Thank you, Antonio. Now I request our Honorable Vice Chancellor, Professor Talat Ahmed, to say a few words.
Good morning and Assalamu alaikum. Professor Mitra, Professor Antonio De Felice, Professor Sami, Professor Ghosh, my other colleagues, participants of this GYAN program from different part of the country, and our own students, researchers. This is the third program for the Center for Theoretical Physics under this GYAN scheme of the MHRD, which is very satisfying. In fact, the whole university has been doing well. We have, I think, more than 24 GYAN program under different departments and centers. And I'm very happy to see that you're going to have a very exciting lecture series by Professor De Felice, particularly this perturbation theories, which has lots of implications in terms of understanding the origin of the universe and our own planet and how things have been evolving. So, and it is a very exciting area of science, and I'm very happy to see also that you people deal with ghosts, because I was not knowing that in physics also you have ghosts. So that's good. I hope you will all enjoy your stay in Jamia Millia and also learn lots of new things. I would request Professor De Felice to encourage our youngsters and try to have some sort of long-term interaction and collaboration with the Center for Theoretical Physics, which will be very important. And the idea of GYAN program is that we should have more and more interaction with the outside world, in particular for the youngsters of this country. So I wish a very, very useful deliberations all through this 6 days of lecture series, and I'm sure lots of things will come out for the youngsters who are attending this. Thank you so much.